Just like we did yesterday, we're going to take a quick trip back to first semester and remind ourselves, the better we remember our transformations from there, the more it's going to make sense why these numbers are doing what they're doing. When we had multiplication, but it moved to the inside of our function, how did that change our graph? Horizontally, right? And what do we have to always remember when we look at things inside of our function? Think opposite, right? So when we are doing multiplication, we think reciprocal. So when it said a 3, that actually horizontally shrinks our graph by its reciprocal. Similarly, with the fraction inside, it's still inside, so we use the word horizontal to indicate that it is impacting our x's, right? How wide our graph is. But when it's a fraction, we think opposite, so we would say stretch. Well, that's what's happening to our trig graphs as well today, is that we're going to start putting numbers on the inside of the function. They impact our trig graph just like they would impact any other function. Inside the function is going to stretch or shrink your graph horizontally, opposite of the number we see. So using what we just talked about, this should be a very easy description for yourself. Up at the top, you see a nice normal one sine curve from here to here. We kind of highlighted one curve there. Look at the picture here. The equation, describe what's happening. Picture here, equation, describe what's happening. I'll give you like 30 seconds to get that written down. You can use what we talked about on the last page. It's a very easy explanation. Same explanation. So we start seeing where those numbers are going to show up in our trig graphs. Don't put it on the computer, just give it back to me, okay? Okay, so comparing one sine curve, I have one highlighted in the red up at the top. If I were to do the same thing, remember to complete a sine curve, we start at our midline, we go up to a maximum, back to 0, to a minimum, back to 0. Notice it only took me until pi instead of 2 pi. Give me some words you use to describe or observe that. Shrink, yeah, that's even more specific. Horizontal shrink by a half, right? It took our graph that was 2 pi wide, and now it's only pi wide, right? It took our graph and shrunk it by a half. The next one's a little bit weird to see because it would have run all the way over here, which we don't have in this picture. So you can see the whole sine curve takes you actually an entire -2 to 2 pi, or it is stretching it, right? So shrinking versus stretching, how that looks. How we shrink and stretch our graphs are going to look a little bit different than that, but we'll come back to this. This is actually the more challenging way of showing a shrink or a stretch on your trig graphs, okay? We numbered our x-axis yesterday by thinking about the unit circle. We did not talk about what that's called, but when you represent all of the sine or cosine values that would go around the entire unit circle, starting at 0, and working your way around to 2 pi. That is what's called one period of your graph. And as you can see at the top, the length it takes us to complete one wave of the graph. For a sine curve, what does one period or one wave of our graph look like? It starts at our midline, it goes up to a maximum, goes back to 0, to a minimum, and back to 0. That's what has to happen to complete one full sine curve. To complete one full period or one full cosine curve, we would actually start up at a maximum, go to our midline, go to a minimum, back to our midline, and back up to a maximum. That is what it takes to be one period or one full cosine curve. So new vocab word for us. How do we find that given an equation? Unfortunately, it's not the number that's in the equation. The number that's in the equation is what we would describe as a horizontal shrink or stretch. For our formatting is letter B. So if there is a B, a number in front of your x value, multiplication, in your equation, it will change the length of the period. They are related to each other with a factor of 2 pi. So b is the number that is in the equation. P stands for period. And that is the length of one full curve. They are related to each other but not equal. If b is like 10, the period length becomes 2 pi divided by 10, or pi over 5. Okay? So again, they are not the same number, but they are how we find the other number. It's always 2 pi divided by. They will always give you the one that we don't want. They will always give us the period if we're trying to write the equation. They'll always give us the equation that has a b value if we're trying to graph it. And we will always start by doing 2 pi divided by. So just kind of remember that formula. Doesn't matter which direction you're going, 2 pi divided by. So just identifying the period given the equation. I'll do the first one for us, and then you guys can do the next two. In the equation, y equals sine of 2x, again, the number we see is not the period. That is the b value. It helps us find the period of the graph. So to find the period, we will always take 2 pi divided by the number that was in the equation, in this case 2. Simplify that fraction. And the period then for this equation would be pi, meaning I would finish a full sine curve by the time I get to pi on my graph. Okay, go ahead and identify on the next two, please. Number we see in our equation is the b value. Period is what they will typically ask you for, or we need in order to graph. So 2 pi divided by 4 should be a period of pi over 2, which means we are completing an entire curve by pi over 2, which is really squished. And the last one, just how do we deal with a fraction and dividing? Our b value is 1/2, which means the period is 2 pi divided by 1/2. Remember that when we divide by a fraction, it's the same thing as multiplying by the reciprocal. So it'd be 2 pi times 2 over 1. Multiply straight across the top, straight across the bottom, and we would get a period of 4 pi. Twice as long as the normal to finish one sine curve. Okay? Now, one method of how to show this when you graph is just to use what we had before and squish it into that amount of time, or stretch it out over that amount of time. That is the way more difficult way of graphing this. We're going to kind of cheat the system a little bit, and we are just going to renumber our x-axis to match the period of that particular graph. So how do we do this? When you draw your own graph, there will always be, starting at the origin, 1, 2, 3, 4 lines along your x-axis. We will identify the period of that particular problem. So in this case, b equals 4, so the period is 2 pi divided by 4, or pi over 2. We will label the 4th tick mark as the period. Okay, so we just found out the period is pi over 2. Label your 4th tick mark as pi over 2. You have some minimum requirements when labeling. The 4th tick mark and the 2nd tick mark are minimum requirements. So the 4th tick mark is pi over 2. Half of that would be our 2nd tick mark. Now, fractions always mess with people. What's half of pi over 2? Pi over 4, right? Half of a half is pi over 4, or 1/4. Label that same thing in the negative direction, negative pi over 4, negative pi over 2. Now, can you label all of the tick marks? Yes. Probably not worth your time, but you can. Half of a 4th is 1/8, right? So it would be 1/8, 2/8, which simplifies, 3/8. You don't need to mark those. You can if you want to, okay? Go ahead and try the second one. Given cosine of 1/4 x, label our axis to adjust for that change in the period length. always 2 pi divided by. So 2 pi divided by 1/4 is the same thing as 2 pi times 4 over 1, which gives us a period length of 8 pi. That becomes the label on my 4th tick mark. Half of that is the label on my 2nd tick mark. So 4 pi, negative 4 pi, and negative 8 pi. Now, why are we doing that? Well, if I relabel my x-axis, I now get to follow the exact same pattern that we used yesterday, meaning I start my first dot here, and I go over one line, up, back to my midline at the next line, etc. We don't have to adjust the length between our dots. We've taken care of that by adjusting the labeling on the axis. So let's go ahead and try one of these. And we are going to start putting a whole bunch of our transformations together, not just isolated all the time. F of x equals 2 cosine 6x. There's kind of an order into which we are going to attack this. And the very first thing you want to do is get your axes labeled. Our y-axis is labeled for us, we can see. But we need to label the x-axis. And that comes from if we have a b value other than 1, which we do. Which one is that again, the 2 or the 6? The 6, right? So that's what's going to tell me what the period is. And again, they're not the same, so I have to do a little converting. 2 pi divided by. That is the label on my 4th tick mark. So I put a pi over 3 here. Half of pi over 3, what is half of pi over 3? Pi over 6 is my 2nd tick mark. Those are your minimum requirements for our labels. Our midline is still not going to move. Monday, we'll spend a day on moving the midline. So today, it's still going to stay right there at y equals 0 or your x-axis. We are graphing a sine curve. Oh, no, we are not. We are graphing a cosine curve. Okay, so cosine curve starts off our midline. Normally would start here at 0, 1. But what's going to change that? The 2, our amplitude, right? Remember that vocab word? Our amplitude says that every time I make a dot off of my midline, it needs to be this distance away from my midline. So I would start my graph up at 2. And then we just get to follow our pattern, which means go over to the next line, go back to my midline. Over to the next line, down 2. Jordan?
So the midline isn't 1 even though that's where
Correct.
still always just that.
Correct. Okay. Now what I have drawn this way is one cosine curve. This cosine curve has been completed by the time we got to pi over 3 because of how I altered the numbering on the axis. So instead of me figuring out where pi over 12 is on a normal picture, I got to use the normal marks we had up there because of how I renumbered. Okay. You are expected to fill in all the way across, so just repeat that pattern backwards.
So we don't have to draw the paragraph?
No. Yes. Questions? Okay. I told you we were learning 2 transformations today. Your second one is what's called a phase shift. It's a new vocab word for us, similar to the way that amplitude was a new vocab word for us. Amplitude was the trig-specific way of doing a vertical stretch or shrink. Phase shift is the trig-specific way of moving your graph right or left. Okay, so where can I find it? It has to be inside parentheses, so must have parentheses. If there are no parentheses, it's not a phase shift. It'll be what we do Monday, which is a vertical shift. Okay, so if it has parentheses and there's addition or subtraction inside. Now, I don't love that this is a plus sign. It actually probably should be a minus sign. But just a reminder that your C value will be opposite of what's in the equation. So if it is a positive number, let's put a positive in front of that, positive number, that our graph would move right. In the equation, it would look like x minus that number. Your C value is a negative number. That means we would move left. But in the equation, it would look like plus that number. It's always opposite, just like it was first semester. If we added inside, we moved left. If we subtracted inside, we moved right. Okay. Now, do I have to sit there and move every dot? No. Really, what we need to do is move your starting dot. Once you have adjusted where that first dot is, you just follow the pattern from there. Okay? Now here's what bothers people about the phase shift, is once I've shifted it, it starts looking like the other type of equation. Yeah, they're actually the same dots, pi over 2 away from each other. Okay, so they're all going to look the same. All your graphs are going to look the same, and they should. And if one of them's not, something's going wrong. Okay. So in this first part, a lot of times this chapter, you're going to be asked to just identify properties of the graph. What's your amplitude? What's your phase shift? What's your period? All of that stuff. So when they ask us for phase shift, that is C in our equation, and it will always be the opposite sign that is in the equation. Okay, so as we look at this first one, C is what's being added or subtracted. If it's minus pi, when I actually identify the phase shift or identify C, I use the opposite sign. And it means that we would have moved right pi. Now, to be very clear, you are not allowed to say right pi or left pi. You have to put the correct sign on them. So just make sure that you're doing that. Okay. Go ahead and identify the second one. Correct sign, like on this next one. What will happen sometimes, don't write this because this would be counted incorrect, is that they say that this would move left pi over 2. So if you were asked to identify the phase shift, they would say left pi over 2. But it really shouldn't be left pi over 2, it should be negative pi over 2. Does that make sense? So you can't use the words right or left to indicate. You have to use the correct sign when asked to identify C or phase shift. To us, practically, what does that mean? It means to move left. Okay. So seeing an example of how we graph something like this one only has a phase shift in it. So looking at how we do that, we don't have to adjust anything else. Our x-axis, our y-axis is all exactly the standard way that we would start, because the only change to this one is our phase shift, and that is that minus pi over 2. If it says x minus pi over 2, what's our actual phase shift? Pi over 2, opposite sign, right? And we, again, think opposite of what's in our equation. So if it says minus, we're moving right. So you don't have to change much. You have to change where your first dot starts. In a cosine curve, my first dot, don't draw this because you can't slide yours like I can. My first dot in a cosine curve would start here at 0, 1. In this equation, that first dot is supposed to start to the right, pi over 2. This line is pi over 2. So I went and found pi over 2. I moved my dot. That's where I would start. Now, for our notes today, I am going to tell you where my dot is that I start. That is not an expectation. You do not ever have to write where you started your equation. I can tell based on what's up there, but that's where we would start this, and then we follow our pattern. We are currently off the midline. My next dot has to go to the midline, right? So I would go to my midline, below, back to my midline. That's where it got moved to the right, pi over 2. We continue to fill in our pattern back the other way. So midline below, midline above, midline. It sure is. It looks just like a sine curve, right? And they are. That is exactly the relationship between them. Does it make sense? Think about that unit circle. Go from 0 to pi over 2. Doesn't it go from the order pair 0, 1 to 1, 0? I mean, isn't it just flip-flopped? So doesn't it make sense that they're just pi over 2 away from each other from flipping those signs? So yes, 100% related. All right, let's try one more with the phase shift. Of our transformations up to this point, I would say phase shifts are probably our more challenging ones, paying attention to direction, all of that. 2 sine x plus pi. Nothing needs to change about the numbering. It's already done for us. We'll start by our first dot. Remember that your phase shift, your C value, is opposite of the sign you see in there. Which way should we move this graph? Left. So normally, my sine curve, again, our midline's not moving today, so I'm going to keep drawing that in there. But normally, my sine curve would start at 0, 0. Don't draw that dot because we're going to move it. Left, pi. Pi is right here. Left pi means my first dot would start right there. Once I have that first dot, we just follow our pattern, which says go to the next. And it has an amplitude of 2. So now as I leave my midline, I'm going to go that far. I'm still on my midline right now. So as I go to the next one, I was supposed to go up 1, but we have an amplitude. So now I'll go up 2 instead. Go back to my midline, down 2, back to my midline. I'm going to pause there and show you that's my original sine curve shifted left pi. We always will finish out drawing the rest of that all the way across our graph here. Again, identifying where you start, don't do it. You don't need to, okay? All of that. So yes, they are going to start looking related. As we start writing equations of graphs, there become infinitely many correct answers because you can start any curve anywhere based on a phase shift or an ROX or all of that. So we'll get there eventually. But any questions on your phase shift part? Okay, my little piece of advice before you go into that though, let's say you're drawing your own graph and you put those 4 tick marks out there, but you had an adjustment because it had a b value of 1/2 or something, and let's say it went pi and pi over 2, and we had a phase shift of pi over 2. Well, normally pi over 2 is here, but now pi over 2 is this tick mark, so we'd have to get our point all the way over there to wherever my new numbering says pi over 2 is located. So just be careful if you change the numbering that you match the phase shift to that. Summing up what we've talked about with our A's, B's, and C's. We have one more letter to add on Monday, and that is D. But A, B, and C, mathematically, A is your amplitude. Non-mathematically, what did that mean to us as we graphed it? How high or low, above or below our midline, right? So how far above or below midline. Okay. Now, B does not actually have a name, but it helps us determine something that does have a name. Do you remember what it's related to? Period, right? So it'll help us determine the period. And those formulas were 2 pi divided by p, or p equals 2 pi divided by b, always 2 pi divided by. It doesn't matter which one you have to get the other one, 2 pi divided by. C does have a mathematical name that we just learned, phase shift. And it was how far right or left we moved our graph, and really to us that really meant our first dot, right? Our whole graph is moving that far, but for us it really impacted our first dot. Because once you get your first dot out there, we fill in the pattern. Questions? Okay, half of what we're doing this chapter is graphing. The other half is writing equations. We will write equations from words that are given to us. We will write equations from graphs eventually too. We're just not quite to the graph part of it. So we're going to practice here writing equations. The top gives you like the formatting of how to write these. One thing we did not talk about at the beginning is that if you have both a B and a C value, do you see how they have a double parentheses up here? You have to have a double parentheses if you have a B and a C. First semester, we almost never had both a horizontal shrink or stretch and a horizontal shift. It almost never happened. It'll happen quite often in trig. And if it does, you have to have a double parentheses or the C value is actually wrong. Okay? If you don't have both, you can stick with one parentheses, which is fine. But just be careful that this is not like excessive, that's required. I want to talk through this first one, and then I see a lot of us are I must be feeling comfortable with this. It says sine up there. If they specifically say write it as cosine, I would pick cosine because the problem said so. Really, right now, I don't care which trig function you pick as long as we're getting the numbers in the right place and the correct numbers up there. So reading through my information, it says we have an amplitude of 3. We haven't talked about this today, but we did yesterday. If it says ROX, how's that going to show up in my equation? Negative on which letter? A, right? And then we did talk about this today, period of pi over 4. That helps us find the b value, but it's always 2 pi divided by. So if the period is pi over 4, 2 pi divided by pi over 4, which means multiply by the reciprocal, 4 over pi. Multiply straight across the top, straight across the bottom. Those pi's are going to cancel, right? We end up with a b value of 8. Putting all of that into my equation, negative for the ROX, 3 for the amplitude. They said write it as a cosine curve. I do have a b value, but I don't have a c value. You don't need the double parentheses if there's no c value. In fact, it is okay to write it without parentheses at all. It's also okay to write it with a set of parentheses. If you put double parentheses in there and you put one strictly around the x, that's actually fine too. It's not going to change anything. Any questions? If you have not read through the second two, go ahead and read through the second two equations. I'll give you a second to work ahead of me and get those equations on there. The answer's up there in just a second. Remember that C is our opposite sign, right? Opposite of. Now they give us a word, so we have to indicate that in our equation. Okay, first one, they do give us a phase shift in this one. Anytime there's a phase shift, you have to have parentheses. This is not optional, or it's not a phase shift. So you have an amplitude of 9. They asked you to write it as a sine curve, which is why I picked sine here, and a phase shift of right pi. Remember that in my equation, right looks like a minus. Make sure you have the correct sign there, minus pi. On the bottom one, a lot of things that you had to put together on this one. You have an amplitude here of 5.4, period of 4 pi, which means b is 2 pi divided by 4 pi. Your pi's cancel. Oops, and that simplifies down to 1/2. And a phase shift of left pi over 2. Left, when I write out c, has to be negative. When I put it in my equation, has to be positive. Y equals 5.4 cosine. Because I have a b and a c value, we'll need double parentheses. Let's check you put your double parentheses in the right place. So it says cosine, and you draw parentheses, and then you put the 1/2. And now you have to put a parentheses before you write the letter x. So parentheses splitting the 1/2 and the x, plus 2 pi, finish your double parentheses. What questions do you have for me?